means that you have numbers to plug in, right, instead of the constant at the end. So when we integrate with these, we can do one of two things. We can either keep those original numbers and at the end change our u back to whatever it was and then plug in those numbers. Or we can find new limits based on how we're substituting. For instance, if you have a new function, u is equal to g of x, you plug the lower limit in, and then you plug the upper limit in to get your new limits. I'm going to show you by example here. I think it's easier usually to go ahead and change these limits because it's really just a simple calculation, and that way you don't have to sub back in at the end. But I will show you both options. So if I ask you to integrate this, we've been picking our u value. We usually try to find like the inside, if there's something being raised to the power, or if there's something under a radical, or something, the argument of a trig function, or the argument of a log. That's our inside function. What's the inside here?
30 minus x squared.
And then we have to find du. Du is the derivative of this. What's the derivative of 30 minus x squared? Negative 2x, and that gets a dx. So if I am looking at this right now, the 30 minus x squared, that becomes my u. But then all I have left is an x dx, which is only this part. What should I do with that negative 2? We can divide that over, so we get negative 1/2 du is equal to the x dx. All right, so if I set up my integral, we have the x dx is my negative 1/2 du. And then this was on the bottom, so what kind of exponent would that be? Negative 2. So this is just a u to the negative 2. Okay. We can change these limits right now if we want. By changing them, I mean this is my x value. So if x is 3, what would u be? So if I plug 3 in here, 30 minus 3 squared is 21. If I change my 5, 30 minus 5 squared is 5. So now everything is in terms of one variable. So we have a negative 1/2 u squared d. So now we can integrate. Negative 1/2 u squared, so that would become a u to the third. You'd have to put a 1/3 in front times negative 1/2 is negative 1/6. We're integrating from 21 to 5. Because those values are u's, right now I do not have to change this back to an x. If I did not change these numbers, I would then have to replace my u with the 30 minus x squared, and it just becomes a little bit uglier. But because I already found my new limits, we can just evaluate this. So we have negative 1/6. So we have to do 5 to the third minus 21 to the third. I missed something, didn't I?
Yeah.
I dropped my negative right there. So this is wrong.
Speak up, Chris.
Yeah, why didn't you guys say something? Come on. Okay, if I add 1 to this power, if I hadn't dropped that negative on my power, that would be negative 1. So put a negative in front, so that would make it a positive 1/2. Sorry about that. So 5 to the negative 1 is 1/5. 21 to the negative 1 is 1/21. So if we evaluate this, and you could use a calculator right here if you had to. So we get 16 over 105 times 1/2. So 8 over 105. So yesterday we always had to change our u back to an x. As long as you find the new upper and lower limits on a definite interval, you don't have to go back to x. Questions? Let's just keep doing it. All right. So we have sines and cosines here. They're pretty equivalent in level of difficulty, but if you had to pick one, which one do you think should be my u? The sine. Why?
Because that was that cubed.
Yep.
So it's higher.
Very good. So u is just the sine of 2t. So du, derivative of sine is cosine. Angle stays the same. Derivative of the inside, derivative of 2t is just 2. And we would get a dt at the end. Do we need all of that?
Yes.
You've got the sine 2t, and then I have cosine 2t dt.
So that.
We don't need the 2, so we have to move it to the other side. So 1/2 du is cosine 2t dt. All right, so if we want to go ahead and change our limits, 0. So just plug it in here. 2 times 0 is 0. What is the sine of 0? Sine of 0, b squared is 0 over 2, so 0. If I plug in a pi over 4, 2 times pi over 4 is pi over 2, or 90 degrees. The sine of 90 is 1. And this would be a u to the third times 1/2 du. Do you guys care if I just write this 1/2 in front? Is that going to confuse anyone? So now everything's in terms of u, so we just have to integrate. Antiderivative of u cubed would be u to the fourth. So we have to put a 1/4 in front, times the 1/2 is 1/8, from 0 to 1. One to the fourth is 1, minus 0 to the fourth is 0. We get 1. Questions on this? So first step, we have to decide what u should be. So what would it?
X plus 5.
So then what's the du?
1.
1, and it gets a dx. So du is really just dx. Okay. So this doesn't appear to have been all that helpful. We've got this taken care of, and we have this taken care of. But I also have another x. What am I going to have to do for it? We did this on the last example yesterday. We have to take this u equation and solve for x. So that means u minus 5 would equal plane x. So if we integrate, -4 is an x value. -4 plus 5 is 1. My upper limit was 4, so if I plug that in for x, 4 plus 5 is 9. My plane x gets replaced with a u minus 5. Then I have a square root of u, or u to the 1/2 d. How is this any better than what we started with? We can distribute this out, can't we? And then be able to integrate. We couldn't before because we had two things under the radical. But now, if we distribute, u to the first times u to the 1/2 is u to the 3/2 minus 5u to the 1/2 d. Right, so antiderivative of u to the 3/2, so if you add 1 to that exponent, it would be 5/2. So we have 2/5 in front. Minus u to the 1/2 plus 1 is 3/2, so you need a 2/3 times 5, so 10/3. Something on to mine. And I'm sure you guys could grab a calculator here and help me out. 9 to the 5/2 means the square root of 9, which is 3 to the 5th is 243. 73 to the 3rd is 27. 90. Yeah, you guys help me out here. $152.15. Equals left, and then you get past. So what should my u be this time? The exponent, so the cosine t. du, derivative of cosine is negative sine t, and that would have a dt. If we look at what we have that cosine. We need sine t dt. We don't need the negative, so I have to divide that to the other side. How is this one different than the others I've been doing? We have that e, and this one doesn't have limits. The upper and lower limits does it. So what will it have at the end? Let's see. Okay. So we have the integral e to the u times negative du, so I'll just pull the negative out in front. Antiderivative of e to a power is still e to a power. We have that negative, so it'll just trail along. And then we have to put plus c. And then, since we don't have limits to plug in at the very end, this is what we did yesterday, you have to replace your u back in terms of the original variable. So u was cosine t. So we have negative e to the cosine t plus c. What's my u? Since this is dx, x is the variable, so a just represents a constant. So the derivative of a constant is 0, so we just get negative 2x dx. If we look, we've got that covered. Then we need an x dx, so I don't want that negative 2, so divide it over. So we're going to integrate. We can go ahead and change our limits. If you plug 0 in for x, a squared minus 0 squared, just a squared. If you plug in a 9, we get a squared minus 81. So far, so good? Right, so this square root, that's just like a u to the 1/2 times negative 1/2 du. So antiderivative, add 1 to the power, 1/2 plus 1 is 3/2. So that means we need a 2/3 times negative 1/2, so negative 1/3. Minus 81 to the 3/2 minus a squared to the 3/2. As far as simplifying this, there's really not much we can do. We don't know a squared minus 81, so I can't do anything there. Really, the only simplifying, what would be a squared to the 3/2? 3. How are you multiply? 2 times 3 over 2 is 3. And that's as far as you can go with this one. So yesterday, I gave you the first chunk, the 3 through 39, every other odd. Today, I want you to add those last 7 problems on. So it is all due tomorrow. We are taking a quiz tomorrow only over this section, so I'll probably do just a little bit of review at the beginning,